Okay, when we look into 11.2, C11.2, what is 11.2? It is something we call it as a convection. What is exactly a convection, people? A convection, it's basically transfer of thermal energy through material. Transfer thermal energy through material, any of the material, by movement of the material itself. By movement of material itself. So usually, whenever we say something is in convection, it only happens in two situations. It only happens in one thing, and that is what we call it as a fluid. You guys still remember what is a fluid representing? Fluid only represents two states. What are the two states? They are and yes, you're correct. So fluid is always referred to only two components or two states. We call it as a liquid or gas. A very good example of showing of the convections, it will be, they'll do an experiment, something like this. Imagine that if this is a beaker, and then they fill it up with water, then what they will do is that at this position here, they will place a component. This component is, we call that as a potassium manganate. Potassium. Why do they place a potassium manganate here? It's very simple. What kind of experiments they will do is that they want to show us that how the convection will work. So then once they place a potassium manganate by the side here, then they apply or they supply heat from the bottom. People, we know that when we supply heat, things will start to boil up, right? So what you will see in this situation here is that this is a pure water, this is a potassium manganate. When they mix it with the water, they will show a specific color, probably it's purple color. Then when you heat it up already, what will happen is that you will see that the color is going upwards this direction, then going this direction, then going this direction, then going this direction. So this, when it goes in this direction, this is what we call it as a convection current. A convection current shows that how it flows of the entire convections. Okay, so that is what we call it as a convection current. You can think of it, convection current is a motion of fluid.
It's not diffusion.
Sorry? Diffusion. Yeah, this is the one. Diffusion? No, diffusion is different.
Because I remember doing this experiment in chemistry.
But you guys call it a diffusion?
This specific experiment.
We don't use the word diffusion in physics, or probably you can use it in chemistry. Yeah, we don't.
Like when they drop the color.
But I don't know whether you can use these terms in physics or not, because usually we don't use the terms here. We only use the convection current. Okay. But another thing is that I want you guys to know is this link to two things. Number one, it's hot, and number two, it's cool or cold. Let me just use a specific words, much easier for me to explain. Let's compare hot air and cool air. Or it can be hot water and cool water, either one, air or water, air or water. What I want you guys to know compared with you is that we know that anything that is hot, is it less dense or is it denser? Yes. Anything that is hot, it's always less dense. Anything that is cool, it's always denser. Logically thinking, if it is less dense, does it float or does it sink? Yes. Anything that less dense is always float. Anything that denser, it will sink. Now, logically thinking, let's see here. When my heat supply here, this part here will be hotter. Hot water rises. When the hot water rises, it flow in this direction. As it flow from here to here, it go down. When it go down, that's where it become cool water or cool air already. When it's cool air already go down, then it goes in always this direction. And these things, therefore, we call that as a convection current because of a hot and cold component. Okay? Everybody get here so far? Enough? So that is how the convection works. Not only that, in some of the houses that there will always be a heater in the house. Like of course in Malaysia there won't be any heater because 24/7 is always summer. Therefore, imagine that if this is a house, and imagine I place a heater here. This is a heater, yeah? How does the convection current work in these situations? What is the usage of a heater? A heater is to heat up the environment in the house. So what they will do is, because we know cool air or cool water, it will be denser. That means that there will be more cool air at the bottom, right? And when there's a cool air at the bottom, therefore you notice all the heater is installed on the ground. They don't install high up. No, never. Why install on the ground? So that all the cool air can go into the heater. When all the cool air goes into the heater, what will happen? They will heat up the gas, so the gas, hot air rises. When the hot air rises, they go this way, then only they go back down as it becomes denser. So this is also another thing that we call it as a convection current as well. And not only for the heater as well, there's another example using the same concept, freezer, fridge, refrigerator. So this refrigerator also using the same concept. Yes. Yes, a conductor, it can be conduct electricity or conduct heat. A thermal conductor specifically only conduct heat. Yeah, a conductor is referred to a material. A thermal conductor is the one that can transfer heat. Yeah, then you can say it's the same. Okay, getting here so far. Okay, now there's one last part that I want you guys to know is some things we call it as a sea breeze and a land breeze. Give me some time to draw it out. Okay, people. Now, what is exactly a sea breeze and what is exactly a land breeze? If you want to think of it, sea breeze only happen in daytime. Land breeze only happen in nighttime. So, what does the sea breeze and land breeze tells us? Now, logically thinking, you guys have learned your specific heat capacity, right? When we talk about water and solid, we know that this one will have a higher specific heat capacity, right? Because they can absorb more heat. This will have a lower specific heat capacity, correct? When you have a lower specific heat capacity, what does it mean to your heat? Do you absorb heat faster or you absorb, do you increase temperature faster or you increase temperature slower? Yes. So that we know this one is increased temperature faster. Whenever it's increased temperature faster, what does it mean? Does it mean hotter, correct? So whenever it is hotter, what will happen is this side of the land, there will hot air rises. You understand? Okay. When hot air rises from the land, what will happen? That this will move it to this direction, and eventually it's being cooled down. When it's cooled down, we know that whatever things go down, it means that is a cool air sink. Correct? When cool air sink, can you see the direction now? It goes up here, it goes down here, it goes from here to here. So this side here, it will be moving this direction. Agree? Can you see that the convection current is going this way? Can you see? So this is my convection current. Therefore, during the daytime, when you walk by the seaside, what will happen is that you feel that the wind is blowing from the sea towards the land. That is what we call it as a sea breeze. And therefore, during the daytime, when you walk by the seaside already, when you get back to hotel, you feel sticky, right? A lot of people will think that, okay, I feel sticky is because the sun is hot, I'm sweating. In fact, it is not. It's because when they are blowing from the sea to the land, we know that sea, there will be a salt in it. When there's a salt in it, when they blow it towards us, the salt will stick to our skin. Therefore, we feel sticky. That is always, remember, sea breeze, it's always the wind blowing from the sea to the land. Yeah? Let's take a look at nighttime. Nighttime land breeze. Whenever it is a land breeze, we know that this one hot air rises here. But in the land breeze, the hot air doesn't rises here. The hot air rises here. Because we know the sea is hotter than the sun during the night time, because this is higher specific capacity. When they decrease in temperature, slower. So this is hotter. When this is hotter than the land, this hot air rises. So hot air will go to here and go to this situation. The cold air denser. When the cold air denser, therefore it blows this direction. Therefore, the convection current is going in this way. And in nighttime, how come when you go back to your hotel, you don't feel sticky? It's because the wind is blowing from the land to the sea. So there won't be any salt that's sticking on our skin. That is the difference between the sea breeze and the land breeze. So always think of it this way. Sea breeze is wind from sea to land. Blowing from sea to land, that's sea breeze. Land breeze is always the wind from land to sea. That is what we call it as a land breeze. So these are the two things that you need to know in terms of sea breeze and land breeze. And that will be the end for the convections. All right, I will start recording, take a photo and send it.